Good morning, students.
Good morning, teacher.
Life is moving. Even we are asleep, molecules what make our body continues move and collide with each other and react. Our molecules move more active than we are. Let's activate ourselves. What will happen if we will more active?
We will be more successful.
With this setting for succeed, let's begin our lesson. Answer a few questions, please. How temperature influences the rate of reaction?
By increasing the temperature, the rate of the reaction will increase as well.
Explain this with the help of collision theory.
With increasing temperature, the molecules have more energy and more collision efficient.
Could we predict rate of reaction if we know that the temperature, for example, increased to 10 degrees?
Yes, as we learned before, the rate of reaction increases to 2-3 times while it increases the temperature to 10 degrees.
How concentration affects the rate of reaction?
When we increase concentration, rate of reaction increases.
Can you explain it? Why?
So when concentration increase, our collision also increase.
How do you think? Could we accurately predict rate of reaction?
We need a formula for calculation.
This is going to be our today's topic. Our topic is rate equation.
Our objectives for today are understand that the rate of a chemical process can be represented by a rate equation, recall the general rate equation, and understand the rate constant and the order of reaction. Today I will carry out an experiment, identify the relationship between the height and leakage rate of water, compare that formula with rate equation, identify the relationship between the concentration and reaction rate, determine the order of reaction and the rate constant, solve problems.
Draw 4 graphs on separate blanks for these equations. We are the physicists and we should explain Paracelsus law and show the formula describing the relationship between the water state and leakage rate of water. Experimentalist, and we should plan and make experiment to determine relationships between the water height and leakage rate of water.
I'm a computer scientist. I have to make a diagram for their reaction and experiment.
Guys, explain me what you're going to do.
We have a burette which contains 30 milliliters of water, and after each 2 milliliters we are going to draw down water and note the time.
Okay, that's all.
Yeah, that's right.
Okay.
Stop. Stop.
Give me results.
So we have a result.
First one is.
First one is
The first one is. Is it 59? Am I right?
Yes.
Second is.
39.
Is it this one or this one?
This.
44 and
Or, well, 39.
59.
49.
Right.
7.
This graph describes the curve of the equation y equal root of x. In this graph we will see a straight line which is parallel to the x-axis.
And the graph of this function, y equal to x, is a straight line. Graph of this equation is a curve.
I have been taking the data from their experiment, and I did graph, and this graph there it's quite similar with her graph, which is y equal to roots of x. So that's it.
In the picture we see the reservoir with water, and the reservoir has some holes with jet. This is the most weakest jet, this is the strongest jet. We see the difference between the two jets. The weakest jets have slower depth than the stronger jet. This is because they have the different depths. They also have the different pressure. That's affected for this jet. In the Tertius theorem, we know that we know the formula. The speeds equals 2 multiply g multiply h. This old equation is square. This gives for us that double h. It is the heat between this normal water and between the hole. If we compare this heat in this heat, we see the big difference, and also this difference affected for the speed. The speed in this water speed in this hole is more it's less speedy than the water in this. The speeds in this water speed in this hole.
You see two equations. As you see, they are similar. This red equation, rate constant, depend of temperature and energy activation. And here you can see concentration A in power x. X similar as 1 divided 2, but it can be 0, 1 and 2.
What is the unit of the rate constant?
I can't answer for your question now, but if you will know what is x and what is y, you can calculate it. How you can determine x and y? Only by experiment.
A rate equation expresses the fact that the reaction rate is proportional to the concentrations of the reactants A, B and C raised to certain powers x, y and z. The proportionality constant K is called the rate constant. Knowing the value of the rate constant is important, since it allows prediction of the actual reaction rate when given the concentrations of the reactants. The larger the value of K, the faster the chemical reaction. The exponents x, y and z are called orders of reaction. X is the order of reaction with respect to reagent A. Y is the order of reaction with respect to reagent B, and so on. Reaction orders are usually small whole numbers, such as 0, 1 or 2. The sum of the individual orders of reaction gives the overall order of reaction. Order of reaction must be determined experimentally. For example, the decomposition of hydrogen iodide is a second-order reaction with respect to this reactant and a second-order reaction overall. The reduction of nitrogen monoxide with hydrogen gas is second order with respect to nitrogen monoxide, first order with respect to hydrogen, and third order overall. Interestingly, the decomposition of ammonia on the surface of a platinum catalyst is zero order with respect to ammonia and zero order overall. This means that the rate at which the reaction products form does not depend on the concentration of ammonia. It is important not to confuse orders of reaction with the stoichiometric coefficients of the reactants in the reaction equation. Sometimes they are the same, as in the case of the reaction of nitrogen monoxide with chlorine, but more often they are not. Reaction order cannot be deduced from the reaction equation. Orders of reaction must always be determined experimentally.
plot graph rate of reaction against concentration of A, and it will like this. This means that reaction is order of reaction is 0. We have any more methods, but all of them are experimental. If the rate unaffected by a change in concentration A, it means zero order reaction. Or another method, it's a plotting graph concentration of A against time. We can see that how the half-life decreases with decreasing concentration. It's zero order reaction. If our graph will like this, it means first order of reaction. Rate proportional A concentrate in power of 1. Directly proportional A concentrate increased by 2, rate increased by 2. And length of half-life is constant. The graph for second order like this. Rate proportional A concentration in power 2, change in rate equal change in concentration in power 2. A concentration increased by 2, rate increased by 2 squared or 4. And length of half-life increase with decreasing concentration.
Nitrogen monoxide, NO, is oxidized by oxygen, O2, to brown nitrogen dioxide, NO2, according to the following equation. The general rate equation for this reaction is as follows, but the orders of reaction X and Y cannot be deduced from the reaction equation. They have to be found experimentally. The oxidation is quite fast, and the kinetics of this reaction can be studied at low concentrations of the reactants. The table shows the results of kinetic studies carried out at a temperature of 20 degrees Celsius. First, let's compare the data in the first and second rows. We can see that doubling the concentration of oxygen doubles the reaction rate. This means that the reaction rate is directly proportional to the oxygen concentration. Therefore, the exponent Y is 1 and the reaction is first order with respect to oxygen. Now let's have a look at the data in the second and third rows. The concentration of oxygen does not change, but the concentration of nitrogen monoxide doubles. This increases the reaction rate by a factor of 4. The reaction rate is proportional to the square of the nitrogen monoxide concentration. Therefore, the exponent X equals 2, and the reaction is second order with respect to nitrogen monoxide. Since we can omit the exponent 1, the rate equation takes the following form. The overall reaction order is 3, given as the sum of the orders of reaction with respect to the individual reactants. What is the value of the rate constant K? It can be found by substituting a set of experimental data into the rate equation. If we use the data from the third row, we obtain that the rate constant for oxidation of nitrogen monoxide with oxygen at 20 degrees Celsius is 4.2 times 10 to the power of 3 moles to the power of minus 2 decimeters to the power of 6 second to the power of minus 1. Of course, the result will be the same value for any other set of data from the table. Notice that in this particular case, the reaction orders are equal to the corresponding stoichiometric coefficients. Remember, though, that this is not always the case.
easy method to write equation. If you know equation of reaction, you can use coefficient 1 and 2. This coefficient will be order of reaction respect A and B. Coefficient of A is 1, A in power 1. Coefficient near B is 2, order respect B is 2. And there is overall order of reaction is 1 plus 2 equal 3. But we must remember that for this method we must know mechanism of reaction. For example, this is same reaction as you see now. But mechanism is another. A plus B react and AB is product. AB plus B produce AB2. As you see, reaction is same. But in our mechanism, first reaction is slow and second reaction is fast. We choose most slow reaction and use it to write equation. Rate equal constant multiply concentration A in power 1 and concentration B in power 1. Why? Because coefficient near A and B are 1.
Exercise 15. Two colorless substances X and Y react to give a colored substance Z. The times taken for various initial concentration of X and Y to produce a certain color intensity are recorded in the table. Which rate equation is consistent with this result?
The equation which will be consistent with the given data will be the answer is C. Rate. The inspection of the first and fourth experiments in the table shows that as iodide concentration is reduced to 1/2 of this value. Also, the time increases by a factor of 2. This means that the rate is reduced to 1/2 of its value. The order of the reaction is unity with respect to iodic ions. A similar reduction in a rate is found for a similar but not identical reduction in peroxide disulfide concentration. This comes from inspection of the first two experiments in the table. The reaction appears to be first order with respect to pyridisulfate. The first order depends on both concentration is covered by Kc.
When the rate of the reaction is investigated experimentally using equal concentration of X and Y, in the presence of sodium hydroxide, it is found that which of the following mechanism for the reaction taking place under the conditions specified is consistent with the rate equation?
So when the rate of the reaction is investigated experimentally using equal concentration of X and Y is the percent of sodium hydroxide. So we should answer for question, which of the following mechanism for this reaction taking place under the condition specified is consists when the rate equation. So correct answer should be in. The rate equation given in the statement should be in slows because rate determining in step in our mechanism involve 1 mole of X aqua and 1 mole OH aqua ions. And also Y should be must take place in this mechanism in fast step. That is why correct answer
In your homework is read pages from 330 to 340 of this book. What did you learn today?
Today I learned about the rate and order of reaction, and also how we should determine this, the order of reaction, and how draw a graph, and how order of reaction affected for rate of reaction. Also, I know that we should choose the slow reaction for writing the rate of reaction.